Welcome to part 3 of the touch switch series. In this video I'd like to show you how I get the circuit in front of you printed onto a PCB, DIY method. The method I'm going to use is the dry resist method. So effectively what we do is print this circuit in front of you onto some transparent film and actually develop it on top of the copper clad PCB. So what we want to do first, we want to get this ready for printing. So I'm going to be using Altium Designer to actually get the print. So there's a couple of steps that you have to do on Altium Designer, and these are this. So if you go to File, Fabrication Output, then Final. Just wait for it to load. Right, at the moment it's this page here represents an A4 piece of paper, so it's clearly too big for how we need it. So the first thing we have to do, if we right click then go to Page Setup, then you'll see on the right scaling, if you click Fit Document on Page and select Scaled Print, and then scale, at the moment on mine it's 2.64, we want that at 1, so 1:1 representation of the actual measurements I've used. So that's right, keep it on landscape, centre, colour set to mono, that usually works well. So wait for that to load. So that's the actual size that we'll be using, but as it is at the moment we don't need none of all this here. So what we're doing now is right click again, go to Configuration, then the only ones that we want checked really is top and holes. I don't need to mirror it. So if we unclick everything else on this page, if you was going to send this to a professional printing house, all you'd do is just download the Gerber files and drill drawings and whatnot. Whichever company you use, I usually give you instructions anyhow, so it's pretty straightforward, but I'm just going to DIY print this. So these all clicked off. Okay, just wait for that to load. So there you go. So what I'll do now is we'll go to print, and what we want is page 1:1, because obviously we don't want all the other pages. So I'm going to print that now, and so there's the actual printout of the circuit onto this transparency film. I've already cut it out, ready for the next process of exposing UV light on photoresist. One thing to keep in mind, you'll probably notice that this has been inverted from what it was on the screen. I've had to invert it because the dry film that I brought was actually sold as a positive photoresist, but it turns out it's negative, so it means I had to invert it. Basically anything that's exposed to UV on the film is going to harden and be the ones that won't etch away when it comes to the etching process. So that's one thing to keep in mind if you're doing it yourself. Make sure that you know if you're buying positive or negative, because it'll make a massive difference. Basically, if I'd have done it with the circuit that you see a moment ago on the screen, all the tracks would have been etched away and I'll be just left with the bare copper. So basically what's black now would have been the copper left, so that's one thing to keep in mind. So right, we go to my developing area and get that transferred onto a PCB. So we're in my developing area, kitchen. So I've cut down the PCB just a bit larger than the size I need. And I've prepared my PCB stencil here. And this is the dry film. The idea with this is that we've got the actual photoresist sandwiched in between two pieces of clear cellophane. So what we want to do now is peel one of the pieces of the cellophane off, and I think the best way of doing it is just to pop a piece of sellotape on one corner and then grab another piece. I am prepared. You can probably hear my kit in the background. And just touch it the other side, and what you want to do is just peel the pieces of sellotape apart, and you should pull one of the top pieces off. The bit that we need is the bluish stuff here. So what we want to do now is to pop it onto this PCB as best you can without any bubbles in there. Some people splash it with water, but with the stuff that I got, that I use, this negative photoresist, is not really that sticky and you can knock the bubbles out of it. So you can put it down. It's a bit like putting on a mobile phone protector. So that's nearly there. Pull that bit of sellotape off if you can. Now what we want to do now is just try and knock all these bubbles out best you can. And I find that if you lift it up a couple of times and pop it back down, you can knock them out. What you want to do then is get yourself an iron, put it on to, well, in the documentation of this stuff it does recommend 100 degrees. I suppose you could put it in the oven for a bit, but I find that an iron works quite well. So yeah, that's pretty good. So my iron's there, my iron's been on. Now I've got it on setting, on this particular iron, setting 2, you know, it's quite warm. Right. Then what I do is just get a plain piece of paper. It's my daughter's homework, but obviously the printer ran out at the time, so it doesn't matter. Put on the top and just give it a bit of an iron. I don't tend to rub it, I just sort of dab it on. I think what this does is just adheres it more to the actual PCB. It suggests, well, it's actually Chinglish instructions that I got with this stuff. It suggested 2 minutes on 100 heat, so I'm assuming that I mean 100 degrees. Just like that. Let's have a look. Yeah, that looks pretty good. You will get the odd little bubble in it, but you just can't help that. So what you want to do, really I should have cut this photoresist exactly the same size as a PCB, but it doesn't matter. So then what you want to do is get your stencil that you printed out on your LaserJet printer. Make sure it's up the right way round, not mirrored. Mine needs to go like that, that's it. Just line it up. My hand's not very steady today. What I do is just take one end. So I've cut the PCB just a bit bigger and I'll do all my trimming after. But right now, as it is now, that's ready to go into the UV unit. So that's where we go now. Right, this is a UV unit I'm using. It's a banknote detector. And I think this particular one is 6 watt. 6 watts. So how I do it, I plonk it under there and I expose it for 2 minutes. And that works just right on 6 watts. So depending on the power of your UV light, you may have to have a little play about with that. So I've got my mobile phone here. Okay. I always use a piece of glass as well, just so it pushes everything down nicely. Get it the right line round. So just pop that under there. Oh, come on. And give it 2 minutes and I'll show you the end result. Right, that's 2 minutes up, so I think I've got good exposure. The way to tell if you've got good exposure, you should be able to see the actual pattern if you lift up the stencil that you use. So as you can see, that's actually come out quite well. Right, don't know if you can see that. There you go. Right, as it is now, we still got that other piece of cellophane on there that we need to remove before we develop it. So what you'll find is that if you give it a bit of a peel off, you'll find that where it's actually been set, that don't matter there. You can see that. You can pull that off. Right, now that's ready for exposure. Exposure's finished, sorry, it's ready to be developed now. Right, so I'll take over to my developer. So there is my developing bath. The developer, you can actually buy a developer that's purposely designed for this job. But if you look on the actual ingredients in the proper stuff, it actually contains sodium carbonate as the main ingredient. Now what I use, and which I'm had a lot of success with, is actual Vanish. Vanish Crystal White Oxy Action, and that actually contains the sodium carbonate, and that's what we need. I don't know if you can see that. Contains sodium carbonate. What I use 300 millilitres of warm water and one of these scoops. Right, next job is to plonk the exposed PCB into that stuff. So there's the PCB. Just plonk that in there usually, and then what you do is just give it a bit of a agitate every couple of minutes and check it over, and I've got a cloth in there that I'll wipe over it as well. I usually keep it bathed in there for about 7 or 8 minutes, usually does the job for me. So I'll show you the finished product when I'm done. So there you have the finished developed PCB ready for etching with ferric chloride. It can be a bit of trial and error, this process, so I don't give up if it don't work first time. It's just a matter of just trying different times. But like I said earlier, with the 6 watt UV source I use, I'll just expose it for 2 minutes using the negative dry film photoresist, and then again with the actual developer I use Vanish Crystal White Oxy Action, and I'll just bathe it in there for about 5 or 6 minutes, and taking note that you're not rubbing away any tracks that you've done. Obviously if you keep it in there too long, it's just going to wash it all away. But if you do find that you do have the odd track that's been washed out or broken, you can touch it up with some nail varnish. That works excellent. But for something like this is ideal. It's not a complex circuit, you know, the spacings between the pads, you know, are quite easily done, this process. So the next thing that we're going to do is etch it, and then it'll be ready for drilling and then components added. Okay, see you at the etching. So right now we're ready to do some etching. I use neat ferric chloride. I don't warm it up. You can warm it up, it will speed the process up. But it's a lovely summer's day, so I want to do it outside. I would recommend doing it outside if you can, because if it spills on upholstery or anything like that, it's going to ruin it, and also your clothes. So make sure you've got your gloves on and eye protection, because it's dangerous stuff. So what we're trying to achieve here is we're going to etch away all this copper, and it's just going to leave us with the traces. So you can see the process straight away. You see it sort of goes sort of off colour. You can see it there. If for any chance you've still got a bit of the resist on there, you can give it another wash and develop, because like I said, it is actually resistant to the ferric chloride. But you can see straight away that it's etching it. So what I'll do, I'll plonk that in there and take it outside and just agitate it as much as you can. I usually give it a bit of an agitate and then leave it a minute or two, go back to it, and then after a couple of minutes you should see the copper being eaten away by the ferric chloride. So that's the etching process complete. It's actually surprisingly quick, actually, doing it in the sun. It etched away within probably about 5 or 6 minutes. It's a bit rough around here, that's where I touched it up with some nail varnish and obviously etched it before it was dry, so that doesn't matter anyway. That's I think that's a 12-volt line anyway, so that's absolutely fine. If you do get any bridges that you can't etch away, you can just sort of router them out with a small drill piece or whatnot. But other than that, it's turned out quite well for a DIY job anyway. I think I'm going to put some cutouts along here anyway, just so we keep that isolation from the mains and the low voltage side. Other than that, next job is drilling. So we'll start that now. So right now we're going to proceed with our drilling. I'm lucky enough to own one of these benchtop pillar drills, but you can still do the same job, just, you know, just using a handheld router, something like that. I'm going to start off drilling the holes for my resistors, and I think they're set at 0.8 of a millimetre. Just another tip that I find very helpful is I'll just swing my my camera round. Is to have the actual component layer shown on the screen, so you know what holes you're drilling, because sometimes it can be a bit of an headache trying to figure out where all the components go when you're just looking at the tracks. So that just gives me something to work with, so I know where all my resistors are. And that, so there you go. Oh, sorry about my crap camera skills. So we go back round. Anyone dizzy yet? We proceed with the drilling. I'm not going to record all the drilling, I'll just drill a few holes and pause the rest. So there you go. So right, so I'll start off here. Yeah, so start off with R1. Just line it up. Yeah, so I've drilled the touch switch and soldered on all the components. I left that out of the video so I didn't see the point of you seeing me solder and drill. So there are all the components on. At the moment I'm just testing it with some my bench light rigged up. So there's, see that's going to go into the switches. The switch plate's going to be this side, so obviously I'm going to design some sort of a piece of metal on the front that we can touch. That's the actual switch to go between the toggle and the time, and there's the time pot. So let's get it switched on. Just switch it on now. So I believe at the moment I just got it in toggle mode. Yeah, so that's toggle mode. And then time mode. There you go. So all I need to do now is get that mounted onto my switch plate, wherever it is, I can't find it. I'm going to do some testing now off camera. I was going to go and solder on a piece of 1.5 flex around there just for the current, but what I ended up doing was just flooding it with solder. That's more than enough to carry what I'm going to be driving anyway. It's only going to be a light in my bedroom, our bedroom. So there you have it. So I'll get my dimmer switch plate and get it mounted and job done. So there's a completed touch switch ready to be wired in. For the actual touch sensor I used an old PIR component that I had lying about. I'm just using one of the legs on that because the casing is grounded, and I've got that soldered onto the capacitive touch part of the PCB. That's the toggle switch, and that's the timer. I just need to put some graphics on there yet. I don't know whether or not I will. And I've just used a spacer there just so it gives us a bit more to play with when we actually put it in the actual knockout box in the wall. I've actually pre-wired these in. I'm just going to use some connector blocks in the actual wiring in switch wire neutral and line from the switch position. So there you go. Next job is to wire it in and job done. Thank you. So there it is, fully installed and operational. Just will show the lights. Yeah, so project done. Yeah, I hope you enjoyed it. I hope it's inspired one of you guys to have a play of it yourself. There's a few little bits and pieces I want to do to put some artwork on here, deckling sort of thing. Obviously a timer going from 2 minutes to 30 minutes, and the switch here from like to like switch mode and time mode basically, and there you have it. So I hope you enjoyed it, and I'll catch up with you again on the next video. Ta-da.